Before I built my project, the first thing I had to find out was what launch angle I needed to use. In order to find out the launch angle, I drew a right triangle. The right triangle is shown with the velocity in the horizontal direction, Vx, and in the vertical direction, Vy. If the side lengths were not equal, then one would be larger than the other and it would not give off the correct launch angle and the velocities that I need in order for the project to succeed. For example, this triangle has a larger horizontal velocity than a vertical velocity, and this triangle has a larger vertical velocity than horizontal velocity. That means that both of these triangles are not at their maximum velocities. The only way for a triangle to have two sides that are at their maximum velocities are if they're equal. If two sides are equal in a 90-degree triangle, disregarding the hypotenuse, then it's a 45-45 90-degree triangle. That means that both of these angles are 45 degrees and these side lengths are equal. This is how I figured out that I needed to make my launch angle 45 degrees for my catapult. In a right triangle with equal side lengths, besides the right angle, both angles must be 45 degrees to maximize each side length and make them equal. Because the side lengths of my catapult are equal, then my launch angle must be 45 degrees. This is the data table showing how I got my horizontal velocity. When I tried out my project, I timed it to see how long it would take to go a distance of 20 meters. It didn't actually reach 20 meters each time I tried it out, but I still got the time and the distance. To calculate the velocity, I had to do the v equals d over t, which is distance over time. So I divided each distance by the time. Then I took the average of the three trials to get the average velocity, which is 8.49 meters per second. To get the vertical velocity, I used the equation of the horizontal velocity times tangent theta to equal the vertical velocity. That was the x component of the velocity times tangent theta, which I used was 45 because that was my launch angle, to equal the vertical velocity, which is the y component of the velocity. I plugged in 8.49, which is what I got up here for my horizontal velocity, times tangent of 45 to equal the velocity of the y component. And it equals 8.49 meters per second. And that's because I used the same x and y velocities in order to get the angle to be 45 degrees. To find the resultant velocity, I used the equation a squared plus b squared equals c squared, otherwise known as the Pythagorean theorem. I plugged in for the vertical velocity of 8.49 meters per second and the horizontal velocity of 8.49 meters per second, and I did 8.49 squared plus 8.49 squared equals c squared. And then I got that the c is equal to 12.01. So the resultant velocity is 12.01 meters per second. For these velocities, I actually went to Ortega Park and had my dad come with me and use my cell phone stopwatch as a timer. I launched a bouncy ball that I got from my brother's cabinet, and we just did as many trials as we could and brought a tape measure to measure how far the 20 meters was. Here's my catapult. So there were a couple things that I had to change on it. At first, when I first tried it out, I had only used 2 bungee cords, these 2 yellow ones, but it wasn't strong enough and I still needed to launch probably an extra 20 feet. So I added another bungee cord, 2 more bungee cords. It still didn't launch that much farther, so I added one last bungee cord right here, used as almost like a slingshot. So when you pull it back, that's when it rests on it. The other thing that was affected was that when I would launch the catapult, the whole project would tip over. To fix this, I had to attach weights to both sides on the back to weigh it down so that the energy wouldn't tip over and it wouldn't lose energy during its release. One of the questions I had to answer was, how did I contribute to the group? Well, I didn't work in a group. I worked by myself, so I did everything. Besides from a little bit of help with cutting some wood and drilling from my dad, I did all the work and built the apparatus. 3 things that I did that meets the quality of a physics honors student is, one of them was to not wait till the last minute to do the project. So I started the week after the project was assigned and started building and cutting and thinking of a design right away. The second thing was going to the park and trying it out and doing all my calculations and everything before. And the third thing is going above and beyond, trying to get the A-level requirements done, and doing the extra credit assignment of taking picture with Mr. Emmert and doing some of the other A-level requirements from the yellow sheet.